Siemens. Just to give you an idea, and maybe some of you had a chance to kind of read through the text and all this stuff, but here's kind of the family of Siemens PLCs, and there's more out there, but we start with the logo, which is basically a fixed PLC with a fixed number of I/O. And then we get into the S7-1200. And the S7-300. S7-1500. And the S7-400. And like I say, there's some older legacy PLCs out there that maybe some of you have seen, but that's kind of in. Let me think about this. It's kind of organized in the capabilities of the PLC. So,
why did the Germans go backwards with their numerals and then capabilities? Because it's like
They were silly.
that's where they often the homework concept.
They were drinking too much beer. It's like,
let's go backwards.
Same with Bradley, 1100.
but in the Siemens family of PLCs, the S7-1200, the S7-1500, those are the newer ones, and the S7-1500 is kind of becoming the workhorse of the factory these days. What do you guys use, Josh? You know? Probably 300s. I don't know. That's an older. That would make sense. 400s are more for huge assembly line and data.
Beautiful graphic, HMI.
Yes. 50-inch HMI.
TV screen for an HMI.
But the S7-1200, that's what we're using here. That's the one we're going to be using here. It's a kind of a fixed, but it's modular too, because we can add like 8 modules into this thing. But just so to give you an understanding, the logo is more developed for like small machine type stuff. S7-1200, probably a small assembly line, I would think. There's still a lot of capabilities there. And then it gets on up into the other stuff. The software that we use for programming, and let me go back a ways, because some of you BMW guys are probably familiar with Step 7, or at least you've heard the name. So Step 7 is a legacy software that Siemens used, and there's still a lot of places that still use it out there. That is a PLC programming software.
I can't zoom in and get it up and see what it is.
And then there's something called WinCC. Has anybody heard of that?
Yep.
WinCC?
I've heard of that. It seems to not pertain into.
S7-400s.
S7-400s? Okay, that makes sense.
Yeah, WinCC.
WinCC software, that's for all the HMI. That's the HMI programming software. So what we're using is TIA Portal, TIA Portal. Totally integrated automation, or whatever that was. And what TIA Portal does is it combines these two. So it's basically taking Step 7 of WinCC and putting it in a nice package. Although it hasn't been updated a lot as far as, it's a lot more user friendly. What do you guys use? What's the newest one? There's TIA Portal, and then there's something
They're
that's,
still teaching TI Portal over
Are they?
that's all the new classes.
Okay.
TIA Portal.
okay.
Unless they change something past month, but that's what they would be doing.
Okay, well, that's good.
That's
So TIA Portal, totally integrated automation, is for the PLC, it's for the HMI, and it also involves programming for drives, for any Siemens drive, just to give you an idea. This is like Studio 5000. Studio 5000 has the PLC program software built in and the HMI stuff also, the factory top, but it's kind of clunky because it's the same way with TIA Portal. TIA Portal does a little bit better job of integrating them all together, but still.
Mr. Chairman, would that mean that TIA is modular in the sense that you have more than one translator?
Yeah, but it's a lot more user friendly than what we did. Yeah.
The TIA portal?
Yeah. It's a lot more user friendly than the Studio 5000. It's a driver, you don't have to do any of that stuff. Just download. You don't have to create these other runtime files and all that stuff. Just download to the HMI and you're good to go. And I will tell you this, I am by no means a Siemens expert, so.
We're gonna learn together.
That's it. But I will tell you this, once you get out of this class, you will know more than the normal maintenance guy about this stuff. I can tell you that. I'm an Alan Bradley guy. That's what I used back in the day.
Some Alan Bradley, yeah. I say about the end of the show. You tell Alan Bradley comes up with some new better stuff. And
That's
it'll
what
work like we
Yeah,
get.
good deal. One point there, Alan Bradley.
Well, that whole plant was Alan Bradley. Oh, yes. That whole plant was.
Let's see.
It's tax cuts and warranties and
Oh, yes.
sometimes it's cheaper just to replace there for one the plant, get a warranty and you don't have to worry about stuff.
Where did I have it?
It's like the robots.
Yeah.
Switch back and forth, back and forth.
Yeah, really. Whoever's got the better deal at the time.
You want to hear something great? We just integrated new equipment into one of our lines, $32 million worth. And the company didn't do the sequencing right on one section. So during shutdown, they have to come back and spend $50,000 of their own money and time to fix some of that stuff.
That's why we was on the body shop cost us exactly. They pay a little extra for it.
Plus
They
the-
guarantee. Just support it.
Yeah.
They pay a little extra money. Everything signed off. No. I had good training of that.
I mean, when you're spending that much, you gotta keep your, reputation.
Yeah. So here's kind of a comparison of the two. Studio 5000's on the right, TIA Portal's on the left. If you look, let's take a look at the I/O configuration.
You got this on.
PLC. Yeah, I think it is. Here's all the I/O configuration in Siemens. You got the PLC, and then you have this digital input, digital output, and so on. Kind of the same thing over here. Compact logic. And then one of the big differences in Siemens is they use code blocks. It's just a word, it's just a buzzword, a Siemens buzzword. But we can compare that to the subroutines, the main routine and the subroutine. And here's the thing, in Siemens, main OB1 is the main routine. Block 1, FC1 functions are subroutines. Subroutines without memory. FB's function blocks are subroutines with memory. And this will all come clear later on, once we get into it. And then we have something called a DB, it's a data block, And that's where all the data is stored for the function blocks. That's how function blocks retain the memory in this thing called a data block. Nothing over the top. And in Siemens, we have, here's the tags, you have tag tables. PLC tags are the controller tags. So all the PLC tags are controller tags. What's the scope of PLC tags? Global. That's right. Yeah, so PLC tags are global. And the program tags in Siemens, they're called local tags. There's not what you would call a local tag table in the project, but that's created in your program blocks, code blocks, the local tag table. It's just like when we do different programs. Remember Alan Bradley, we have multiple programs. We stayed in only one program, the main program. But we can have multiple programs with multiple tag tables. It's just like, okay, yeah, program tags, we stayed in the main program. It's the same thing over here, except if we create local tags in Siemens, the local tag table is actually internal to the blocks. Not a whole lot of difference. PLC data types, we talked a lot about data types in Alan Bradley. What were some of the data types we talked about?
Boolean.
Bold, yes.
Single.
And double letters. Yes. Yep. Boatload of them. To give you an idea, here is a kind of a list of the Siemens data types. This is in the book. I made a note up there, Stennerson, page 45. And I'm going to tell you about this easy book here too here in just a minute. There's something called an easy book. It's like, I don't know, quick start guide, or Siemens for dummies, whatever. So here's all the data types that Siemens use. And I would venture to guess that this is not the complete set of data types. Bool, byte, word, double word, character, single integer, integer, double integer, unsigned, single integer. Look at the unsigned data types. What's the difference between the unsigned data types? Unsigned single integer, unsigned integer, unsigned double integer, and the regular data types. What's the difference between the two?
One's unipolar, one's bipolar.
Yeah. Yep, that's exactly right. So the unsigned data types, they only go in the positive direction. And of course we have real, long real. Siemens uses this time data type for like a clock, any kind of real world clock stuff. String, date, time, long, so on, just to give you an idea. So very, very similar to Alan Bradley. One of the main differences with Siemens is addressing. The tags are addressed in a byte level. So we use byte addressing. Instead of word addressing, we use byte addressing. So just to give you an example, let's say we have a 16-point input model. What's 16 point mean?
It has 16 points for you.
That's 16 inputs, right? Yeah. 16 inputs. Siemens world, this module is broken down into separate bytes. And if this is in the first slot, this will be byte 0. The first 8 inputs is byte 0. The second set of inputs, what byte number is that?
Byte 1.
Byte 1. And then we're going to do some addressing here in just a second, but I'm going to add another module in. Sitting right next to this one, another 16-point module. What's the first byte in this one? Byte 0, byte 1,
Byte 2.
byte 2. Yes. So there's byte 2, and byte 3, and so on. That's how we address and see them. Instead of by slot number, by byte. Let's go through some examples of addressing. So we said this was a 16-point input module.